All right, these next two theorems provide more ways to write proportions here. So the first one here, they don't have names to them. The first one here says, if three parallel lines intersect two transversals, then they divide the transversals proportionally. Okay, so what this is saying here is, so I have, of course, here are my parallel lines that are marked, and then I've got my transversal. So what it's saying is, this segment here, UW, and I'm going to maybe rewrite this color-coded. Oops, it's saying that UW in a ratio with the other side, WY, is equal to the same thing on the other side, VX over XZ. Okay, so basically it breaks those four segments proportionally. And so notice the pattern of the proportion. I have here this segment in the numerator of the first ratio, and then this corresponding segment in the numerator of the second, right here. So we can't just be mixing up our ratios, or else we didn't write that proportion correctly. Okay, the second one, I guess. If a ray bisects an angle of a triangle, so just a reminder here that when I see this equal segment, those equal angles, that means that red ray has bisected it, or split it in half. Then it divides the opposite side, so it's referring to this side. Then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So that's a little bit confusing. So what I look at here is basically I'm going to take these two segments are proportional to their corresponding sides of the triangle that they're kind of next to. So this is saying here, let's do some colors again. Let me just get rid of those arrows. So this is saying that AD over DB. Okay, so I'm basically taking the one, so really I'm looking at, you might even look at this as two triangles. Okay, you might even look at this as a triangle over here and then the other one. So it's saying AD over DB, so the two short sides that the ray has gone through, is equal to AC, or CA, over BC. So what I want you to notice are these two sides right here really come out of the same triangle, so to speak. So see how AD comes out, is right here, and AC is right here. So they both come out of this same side, or this is also a triangle. They both come out of this side. Okay, and the same thing over here. We've got DB is in the bottom, BC is in the bottom. Okay, so I have like segments in each part of the fraction. Okay, let's take a look at number 3. In the diagram, angles 1, 2, 3, and 4 are all congruent. So you can see them marked right here, 1, 2, 3, and 4. And AB is 21, so I have that labeled over there. BC is 28, that's also labeled, and EF is 32. Find the length of DE. I want to find this length. So let's just call it X for now. Okay, so here's what I see. Let me highlight. If this segment is, if that angle is congruent to that angle, then this line is parallel to this line. And that is because those are corresponding angles, and those corresponding angles are congruent. Okay, so I'm going to say line L is parallel to M. I'm going to use these names right here. And then that's the corresponding angles converse. Let me write that a little bit better. Angle apostrophe S converse. And then if number 3 and number 4 are congruent, those are alternate interior angles, therefore the lines are parallel. So line N is also parallel. So then I can write M is parallel to N. That's the alternate interior angles converse. Okay, so in essence, all three lines are parallel to each other. So you could do one big transitive to say L is parallel to M is parallel to N. So what we have here, though, what I want you to notice, is we have the very top theorem. We have three parallel lines intersecting two transversals, so it's going to divide it proportionally. All right, so let's write that out. So I'm going to say that I'm going to take 21 AB in a ratio with 28. Okay, 21 in a ratio with 28. I'm going to write a corresponding ratio of the other side. That would have to be x over 32. Okay, and so now from here, we cross multiply. So that will give me 28x equals, so I need to do 21 times 32. 21 times 32 is 672. And then divide by 28 gives me 24. So DE equals 24. Okay, so that's that first theorem. Let's take a look at the next example. Will help us process through the second theorem. All right, in the diagram, ABD is congruent to CBD. All right, so here's ABD right here, congruent to CBD. So I have a ray or a segment, in this case bisecting the angle. Use the given side lengths to find the length of segment AD. And so that one's already marked X, okay? So I need to, let me go to the top here, I need to create a proportion where I had short length. So really, I'm looking at where that ray or segment is, what the other side of the triangle it's bisecting. So one ratio will be those individual segments. The second ratio picks up the sides, all right? So I'm going to do here, I'm going to start with letters. I'm going to take the sides that the segment is intersecting. So I need to put into a ratio AD over DC. Okay, that's the kind of the base of the triangle. And then I need a second ratio. Since I started with AD, I have to go with that same side of the triangle. So BA over BC. All right, so AD is clearly marked with X, but DC is not labeled with an amount. But if I know that this whole thing is 33 and AD is X, well, if I subtract those two, I'll get DC. So I'm going to have to write it like this. I'm going to have to write it as 33 minus X. Because really, if I add those back together, I get 33. So 33 minus X. BA is 45. And then BC is 54. All right, cross multiply. So I'm going to have 54X equals... the other one, I'm going to start out as 45 times 33 minus X. And I'm going to do parentheses because I need to multiply 45 by both parts. 54X equals. So 45 times 33 is 1485. Oops. Minus 45X. So let's take 45X over here. So I need to add it. So 54 plus 45 is 99. 1485, and now I can divide. 1485 divided by 99, it gives me exactly 15. Find the length of AD, so that is the one with X on it, so that is my length here. So AD equals 15. So sometimes you have to create a expression to match or to get the segment you want, but if you have the total, then we can just write it sometimes in the format I have here. All right, so those two examples talk about the next two theorems. I'm going to do a third video. The last page, there are 3 examples for you to try. So I want you to try those, and then when you're done, or if you get stuck, come back to the third video and I will